Hello everyone, it's Miss Stover again. Today we're going to be talking a little bit more about periodic trends. This is an activity that you worked on. There are going to still be some things that you don't understand, but don't panic. It'll be just fine because we will go back to this and look at this again. So here is the graph that you should have made. This is what your graph should look like generally speaking. Notice I've also written in the symbols for the elements so that we can more easily recognize what's happening. And very clearly what I see here is that I have element He, element Ne, element Ar, and element Kr are all the highest elements. Then I see element Li, element Na, and element K are the lowest elements, the least ionization energy. So He, Ne, Ar, and Kr have the most ionization energy of all the atoms that we graphed. Li, Na, and K have the least ionization energy of all the elements that we graphed. So we can kind of develop something from there. We can say that these elements have the highest ionization energies, and they are in a group called the noble gases. So the noble gases have the highest ionization energy. And since ionization energy talks about the ability for something to form an ion, which we don't understand yet, it will make sense later on why those have that. So we'll add that piece a little bit later. You can also see down here, these elements are also part of the same group or family. They are called the alkali metals. The alkali metals. And they are the lowest ionization energy. Again, we'll figure out why they're the lowest and why the noble gases are the highest. Now I want to look across the period. Now remember, a period is a row. So if we look at a row on the periodic table, we'll start with the first row. The first row includes H and He. Notice as we go across the row, we go up in ionization energy. Does the same thing happen in all of the periods? Well, let's look. This excuse me. The second period starts with lithium and goes all the way to neon. So there's the second period right there. And notice what's happening. The general trend is that we are going up in ionization energy. Does that happen with the third period? The third period is sodium through argon. And you'll notice between sodium and argon, generally speaking, I know there's some dips, but generally speaking, the ionization energy goes up. Does it happen for the fourth period? Well, if we look, we can see that we have a little bit of a flattening out, but generally speaking, it continues to go up. And then if we go to Kr, we can see it definitely goes up. So if we look at this, we definitely see a trend of going up. Now, when we get to that fourth period, we also see that the trend kind of lessens. In other words, it declines a little bit. It's not as steep a slope. It's a little bit of a less slope, but it's still increasing. So across the period, we can say that ionization energy increases from right to left. Or no, I'm sorry, left to right. Left to right. So, and wrap up here. The family with the highest ionization energy is the noble gases. We know this because according to the graph, they're always the highest in their grouping. As you travel down the group, the ionization energy gets lower for each element. So He is higher than Ne, Ne is higher than Ar. What that tells me is that the member of the group that's highest will have the highest ionization energy in that group. It also says that because the noble gases have the highest ionization energy, that He is the element with the highest ionization energy according to this trend. And the element with the lowest ionization energy that we can see there would be francium, because as we go down the group, the ionization energy gets lower. So this will have the lowest ionization energy. Okay, and again, we'll understand a little bit more later why this is happening. This will completely make sense when we start talking about this idea of an ion and what that means. So don't panic right now. So going across the period, ionization energy generally increases. We know that there are those dips and valleys, but generally speaking, from left to right, we see that there's definitely an increase in ionization energy from the alkali metals to the noble gases. So pretty simple. That's basically what I'm asking you to do for all of these graphs. So let's look at the next graph. The next graph is atomic radius versus atomic number. Here's what the graph should look like based upon my Excel file. So we can see H is the highest one here, Li is the highest here, Na is the highest here, K is the highest here. Well, we know something about these three elements. These three elements are alkali metals. Sorry, my writing ended up looking a little crazy. That should be a K right there. Okay. Then we look at the bottom rung. Let's look at the bottom rung. So we see HE, NE, AR, and KR. Again, we know something about those. We saw those in the last ones. They were in different positions, but we saw them. These four elements are noble gases. So once again, we have something with these two far left and far right groups and families that we're seeing something happening with. In this case, the atomic radius, that means the size of the ball of the atom, is biggest with lithium, sodium, and potassium. The alkali metals are bigger. And the noble gases are smaller. Now, there's something about this that makes us kind of go, because what we know is, comparatively, lithium has fewer electrons than neon. And that doesn't make sense to us, because if lithium has fewer electrons, it should be smaller, right? But we're going to talk a little bit more about that and gain a better understanding of why lithium, even though it has fewer electrons, is actually bigger than neon that has 9 more electrons than a lithium atom. So don't panic. It's all good. We're going to get there. You just need to know the basics here. We see the basics. The alkali metals are the highest atomic radius. The noble gases are the lowest atomic radius. And then we want to look at the period. What's happening across the period? Well, we can see from hydrogen to helium, it's going down. From lithium to neon, it's going down. From sodium to argon, it's going down. Remember, a period is a row, a horizontal row. Then from potassium to krypton, again, we see going down. One more time, when we get into these transition metals, we see that the slope of the slope of that line is kind of decreasing a little bit. It's flattening out a little bit, but it's still decreasing. So the last one that we were looking at, let's recap atomic radius. The family with the highest atomic radius is the alkali metals. Yes, I know that that's not making quite sense to you, but we'll get there. According to the graph, they're always the highest in their grouping. As you travel down the group, though, as we look down the group, we see that Li is actually lower than Na. So as we go down the group, we get higher. So what does that tell me? Well, it tells me that the person on top of the group is the lowest in the group, and the person on the bottom is the highest. So if we know that the family with the highest atomic radius are the alkali metals, and we know that it gets bigger as we go down, we can determine that francium is the largest atom. So what is the smallest atom? Well, that's pretty easy too, because again, the smallest atom would be on top of the group with the smallest atoms, and that would be the noble gases. So helium is the smallest atom. Okay? Then we look at the period. Going across the period, the atomic radius generally decreases overall, with the alkali metals being the greatest and the noble gases being the least. So as we go across, we see a decrease. And again, I understand. You know that we're gaining electrons, and that doesn't quite make sense to you, but we will be talking about why that happens when we get back from our break. So last graph was electronegativity versus atomic number. So let's look at this. We can definitely see that there's something weird going on here because we have lines with breaks. We don't have a continuous line. So we do know something. We know that the noble gases do not have electronegativity. That's kind of in and of itself a pretty important factor. And again, I'm going to say it again. We're not going to explain that right now. We're going to explain it a little bit later, but we will get there. So don't you panic. So let's look at what is going on here. So we can see here we have fluorine, we have chlorine, and we have bromine over here. And they happen to be the highest of all of the elements. So when we look at the pattern we're seeing, we see fluorine is the highest in its pattern, we see chlorine is the highest in its pattern, and we see bromine is the highest in its pattern. Then when we look at the lowest, we see the lowest are lithium, sodium, and potassium. So once again, these guys are in the same family. They're in the family of halogens. So the halogens have the highest electronegativity. Okay, and we see that the alkali metals have the lowest. Oops. Okay, so we can see that pretty clearly. We can also see that as we're going across the period, remember, periods are horizontal rows. So from lithium to fluorine, we go up in electronegativity. So something gets more electronegative as we go across the period. So lithium is the smallest and fluorine is the largest in that period. Then we look at sodium to chlorine, and again, we see an increase. And then once again, the pattern that we see in the next portion isn't surprising to us because we've seen this before. We see a lessening of the slope of the line, but we still see a general increase. We still see a general increase. So that's what we are looking at with electronegativity. And again, I'm going to say we are going to understand more about what these things are and why all of these patterns that we're seeing make sense. I just want you to be able to read the graphs and determine the patterns based upon the graphs. So here we go as a recap. Electronegativity. The family with the highest electronegativity are the halogens. The family with the highest electronegativity is. As a matter of fact, this word is because family is singular. Okay? Is the halogens. So we know that very, very clearly. We also see the reason why. The reason why, according to the graph, they are always the highest in their grouping. So when we look at it, fluorine is the highest, then chlorine, then bromine is next. So we have that. Now, as you travel down the group, the ionization energy gets lower for each element. So fluorine is higher than chlorine is higher than bromine. Then we know that as going across the period, ionization energy will generally increase overall. The alkali metals are the smallest, the halogens are the greatest. So when we think about this, we can determine a few things. First of all, we know that the noble gases do not have electronegativity. Okay, I'm not sure if you understand that. There is no electronegativity there, none. Okay, so we're not even considering those at all. So if we look at this, which element on the periodic table has the highest electronegativity overall? Well, we've got to look. The family with the highest electronegativity are the halogens, so we're looking there first. Then we have to look. As we travel down the group, what's happening? The ionization, I'm sorry, this should say electronegativity. There's a mistake here. This should say electronegativity. So should it right here. Sorry about that. Okay, replace those words for me, please. The electronegativity gets lower for each element as we go across. So that means fluorine is the highest electronegativity. So what element has the lowest electronegativity? Well, if we get lower as we go down the family, that means the lowest ones are the alkali metals. So francium has the lowest electronegativity. Okay, so hopefully you've gotten this and you're going to be prepared for the test on Friday, and you'll have all of your journal done to turn in next week. Thank you very much.